Okay, this is the notes for Unit 3, Day 5, graphing from intercept form. Before we get into today's lesson, I'm just going to quickly review the two forms that we've talked about previously. This first one, standard form. Remember, in standard form, we have ax squared plus bx plus c. So the number in front of x squared is a, the number in front of x is b, and then the constant is c. And the thing we want to remember about C is that in standard form, this tells us the y-intercept. Okay, so to graph y equals negative 2x squared plus 4x plus 2, we basically have three steps. So step one is to find x. And to find x, or the axis of symmetry, we take the opposite of b divided by 2a. So the opposite of b would be the opposite of positive 4, so it'd be negative 4, divided by 2 times a, so 2 times a negative 2. So we get negative 4 divided by negative 4, which is a positive 1. Okay, so what that tells us is two things. So coordinate of the vertex, which is also the axis of symmetry. So the axis of symmetry would be x equals 1. Okay, so these two are always going to be the same. The axis of symmetry and the x-coordinate of the vertex are both always going to be the same. Okay, step two is after we find x, then we're going to find y. And to find y, we plug in our answer from x into the equation for x and find out what y is. So y is going to be a negative 2 times 1 squared plus 4 times 1 plus 2. So 1 squared is 1, negative 2 times 1 is negative 2, plus 4 plus 2. So y equals 4. Okay, and so that represents the y-coordinate of the vertex. So we know the vertex, and now once we know the vertex, then our last step is to find the rate. And to find the rate, we always multiply a, which in this case is negative 2, times 1, 3, 5, 7. So we would get negative 2, negative 6, negative 10. Okay, and that's all the information that we would need to be able to graph it. So the vertex is at 1, 4. The rate is negative 2, negative 6, negative 10. So we'll just do a real rough sketch over here. So vertex is at 1, 4. So here's the vertex. Okay, the rate, negative 2, negative 6, negative 10. So from the vertex, I would go down 2 over 1, down 2 over 1. And then from this point, I would go down 6 over 1. And here's my graph. Okay, if I take a look at this, so positive 2, that is our y-intercept. And if we look here, that's exactly where a graph crosses the y-axis. Okay, so if those two match up, that's one way to check to make sure you've graphed correctly in standard form. Okay, let's take a look at this next one. Okay, so step one, find x. So opposite of b, so negative 4, divided by 2 times a. So 2 times negative 1. So I have negative 4 divided by negative 2, which is a positive 2. Okay, so again, here's what that tells us. So that tells us the x-coordinate of the vertex and also the axis of symmetry. So the axis of symmetry would be x equals 2. Okay, once we find x, find y. So we're going to plug this value in for x. And when I plug it in for x, it would look like this. So it would be the opposite of a positive 2 squared plus 4 times 2 plus 3. So to evaluate this, 2 squared is 4, then times -1, so that'd be -4 plus 8 plus 3, so y equals 7. Okay, so the vertex is at +2, +7. Axis of symmetry is x equals 2. The rate for this problem, so a, which is a -1, so we're multiplying -1 times 135, so it'd be -1, -3, -5. So vertex is at +2, +7. Okay, so here's the vertex. The rate, -1, -3, -5. So from here I would go down 1 over 1. Do the same thing on each side of the vertex. From the point we just found, we would go down 3. So 1, 2, 3 over 1. Down 3 over 1. Then from there I would go down 5 over 1. Here's my sketch. Okay, and so here's what we know. We know the y-intercept is at +3, which matches up with C in the equation. So that kind of is just a quick double check that I'm correct. And that is it. Okay, the next one, vertex form. Okay, so these are the easy ones. Vertex form, everything we need is given to us in the equation. So to find the x-coordinate of the vertex, we take the opposite of the number inside the parentheses. So this is -2, so the x-coordinate would be a +2. That's the x, and then the number outside the parentheses is the y, and that stays the same. So the vertex is at +2, -6. The rate would be a, so 2 times 1, 3, 5, so it'd be 2, 6, 10. Okay, draw our graph. So 2, -6. Okay, so here's +2, -6. The rate, 2, 6, 10. So from this point up 2 over 1, up 2 over 1, then I would go up 6. So 1, 2, 3, 4, 5, 6. Up 6 over 1, up 6 over 1, and there's our graph. Okay, then the last example of vertex form. So the vertex is at -3, +3. The rate, so a is -1. So -1 times 135, so -1, -3, -5. So the vertex, -3, +3, is right here. Okay, then use our rate to graph it. So I'm going to go down 1 over 1. Then I would go down, so go down 1, 2, 3 over 1. Then I would go down 5, 3, 4, 5 over 1. Okay, and there's our graph. Okay, so standard form and vertex form, that's what we covered last week. And then today we're going to talk about intercept form. Okay, and so in intercept form, this kind of goes back to, and we hit on this a little bit in the last unit. But this equation right here, this is in intercept form. So if you remember from the last unit, is that when we were factoring, we would factor and then we would set what's inside each parenthesis equal to 0, and we would solve for x. And when we solved for x, these solutions represent the points on the graph where it crosses the x-axis. So it crosses at +2, and it crosses at -4. Okay, and we call these the x-intercepts because that's where they cross the x-axis. Okay, the axis of symmetry. So this line that goes right down the middle of the graph, okay, this kind of splits it in half. Okay, that's the axis of symmetry. So right here, this line is at -1. So the axis of symmetry would be x equals -1. Um, and the vertex, down here at the bottom of the graph, the vertex, you can see is at -1, -9. Okay? All right, so let's take a look at this first example. Okay, so we have g of x equals x minus 3 and x plus 1. Okay, so the first step, let's find our intercepts. So to find our intercepts, set each of these equal to 0 and solve. So x equals 3 and x equals -1. Okay, so the graph is going to cross the x-axis at 3, at +3, and -1. Okay, then the next thing we need to find is we need to find the axis of symmetry, so halfway between these 2 points. So halfway between 3 and -1, anytime I want to find the halfway between 2 numbers, we can average the numbers by adding them together and dividing by 2. So we have 3 plus a -1 divided by 2, so that'd be 2 divided by 2, which is 1. Okay, so the axis of symmetry is right here, halfway between them. So the axis of symmetry is x equals 1, which also tells us the x-coordinate of the vertex. So the x-coordinate of the vertex is going to be at +1 as well. And then anytime we know x, in order to find y, we can plug 1 in for x. So if we go back to our original equation and we plug 1 in for x, instead of x minus 3, it would be 1 minus 3. Instead of x plus 1, it would be 1 plus 1, okay, because we're plugging 1 in for x. Then solve for y, so we get y equals a -2 times a +2, so y equals a -4. So the vertex is at 1, -4. The axis of symmetry is 1. And then the other piece of information we need to be able to graph it is the rate. And for this one, since the number in front of the parentheses, so A, the number in the very front here, there's no number. So if there's not a number there, then it's automatically a 1. So the rate would be 1, 3, 5. Okay, so the vertex is 1, -4. Okay, so +1, -4. So this point right here is the vertex. The rate is 1, 3, 5. So from this point, up 1 over 1 on both sides. Then from here, up 3 over 1. Okay, and that's a good thing because when I went up 3 over 1, that matched up with where our x-intercepts are at. And then if I wanted to keep going, then I would go up 5 over 1. And here's my graph. Okay, so to answer some of these questions, the x-intercepts, we already located those. So the x-intercepts are at 3, 0 and -1, 0. The y-intercept, so if we come over to the graph over here, we see that it crosses the y-axis at 0, -3. And then the vertex is the lowest point, so it's a minimum. The domain is all real numbers, and the range from bottom to top, so lowest y value to largest y value. So the graph starts at -4, and it goes up to +infinity, and that's the range. Okay, example 2. So we have f of x equals the opposite of x plus 5 and x minus 1. Okay, so first step, find your intercepts. So the intercepts, opposite of these numbers here. So our intercepts are going to be at negative 5 and positive 1. Okay, so x-intercepts, negative 5, 0, and 1, 0. Okay, then from the intercepts, we need to find the axis of symmetry. So halfway between negative 5 and 1. So we have negative 4 divided by 2, which is negative 2. So axis of symmetry, so halfway between our two intercepts is negative 2. So what that tells us, again, so we know the axis of symmetry is x equals negative 2, which is also the x coordinate of the vertex. So that's also negative 2. Okay, once we know x, then we're going to plug negative 2 in for x, and we're going to solve for y. So we get y equals the opposite of negative 2 plus 5 times negative 2 minus 1. So that'd be the opposite of 3 times negative 3. So negative 1 times 3 is negative 3. Negative 3 times negative 3 is positive 9. Okay, so the vertex is at negative 2, positive 9. So here's the vertex. The rate, since a is a negative 1, the rate is negative 1, negative 3, negative 5. So from the vertex, down 1 over 1, then down 3 over 1, then down 1, 2, 3, 4, 5 over 1. That matches up with our x-intercepts. So that's good. That confirms that we've located the vertex correctly. And there's our graph. Okay, the y-intercept. So 1, 2, 3, 4, 5. The y-intercept is at 0, 5. The vertex this time is a max. The domain, all real numbers, and the range. So from bottom to top, it's from negative infinity to positive 9. Okay, next example, first of all, finding our x-intercepts. So we have an x-intercept at negative 1. So remember, take the opposite of what's inside the parentheses here. So we have an x-intercept at negative 1 and positive 1. Okay, this time the axis of symmetry is easy. Halfway between 1 and negative 1 would be 0. So axis of symmetry is x equals 0. So the x coordinate of the vertex is 0. So now to find y, plug 0 in for x. So we get y equals 3 times 0 plus 1, which is 1, 0 minus 1, which is negative 1, and then 3 times 1 times negative 1 is negative 3. So our vertex is at 0, negative 3. So 0, negative 3 is right here. The rate this time, so a is 3. So 3 times 1, 3, 135 would be 3, 9, 15. Okay, so from the vertex up 3 over 1. Okay, that matches up with our x-intercepts. And then up 9 over 1. And here's our graph. Okay, so our x-intercepts, 1, 0, and negative 1, 0. The y-intercept, so it crosses the y-axis at 0, negative 3. The vertex is a minimum. Domain, all real numbers, and the range, so it's going to go from -3 to positive infinity. Okay, now we're going to work to find the equation given the graph. So let me write up here first of all so we have a times x minus p, x minus q. Okay, so p and q represent the x-intercepts. And a is the number in front. So in this problem, the part that we've got to do a little bit of work to find is we've got to work to find a. The intercepts are easy. The intercepts are at -2 and +6. So we would have a, which we don't know yet. And then since it's -2, it would be x plus 2. And +6, so it would be x minus 6. Okay, so the opposite of +2 is -2, so there's one intercept. The opposite of -6 is +6, that's the other intercept. Okay, so now what we've got to find is we've got to find the value of a. So to find the value of a, we're going to pick a point on the graph. So typically the point that I choose to use if it's available is the y-intercept. So the y-intercept is at 0, 6. And so what we're going to do to be able to find the value of a is we're going to plug 0 in for x, we're going to plug 6 in for y, and then we're going to solve for a. So what that would look like is this. So we would have y equals a times, and then we're plugging 0 in for x, so it's going to be 0 plus 2 and 0 minus 6. Whoops, sorry. I forgot to plug 6 in for y here. So again, we're plugging 0 in for x, we're plugging 6 in for y, so we get 6 equals a times 0 plus 2 times 0 minus 6. So 6 equals a times 2 times a -6. So 2 times -6 is -12. So we have 6 equals -12a. Then to solve for a, we divide by -12. And we find out that a equals -1/2. So that is the value that goes here in front. So a is a -1/2. And so this is the equation that represents the graph. Okay, then it asks us for the vertex. Okay, so the vertex, we can identify that by looking at it. The vertex is right here. And that is at, what is that, 2, 8. Okay, so the vertex is at 2, 8. Remember that the x-coordinate of the vertex is always the same as the axis of symmetry. So the axis of symmetry is x equals 2. The x-intercepts are -2, 0 and 6, 0. The y-intercept, that's the point that we used to find a. That is 0, 6. The vertex is a maximum. The domain, all real numbers. And the range would be from -infinity to +8. Okay, all right, so now let's try this one. Okay, so this time if you look at the vertex is not at a point where the grids meet. So this time we've got to do a little bit of work to find the vertex. But we do know what the intercepts are. So the intercepts are at -2 and 3. So when I write my equation, so we're going to have y or f of x equals a times, and then since one of my intercepts is -2, it would be x plus 2. The other intercept is +3, so it would be x minus 3. And now pick a point to plug in. for x and y to be able to solve for a. So let's pick, well, so again, we can pick the y-intercept. So the y-intercept is at 0, 6. Okay, so this point right here is 0, 6. So we're going to plug 0 in for x, and we're going to plug 6 in for y. So when we do that, we have 6 equals a times 0 plus 2 times 0 minus 3. So we get 6 equals a times 2 times negative 3. So that would be 6 equals negative 6a. Divide by negative 6. And a equals a negative 1. So we wouldn't put a negative 1, but we would just write, whoa, we would write in front here just a negative sign. So here's our equation. And now we've got to do a little bit of work to find the vertex. So to find the vertex, we need to first of all find the axis of symmetry. So the line that would go right down the middle here. So halfway between negative 2 and positive 3 would be 1/2. So 1/2, x equals 1/2 is the axis of symmetry, which means that the x coordinate of the vertex is 1/2. Then to find y, we would plug 1/2 in for x. So we would have y equals the opposite of 1/2 plus 2 times 1/2 minus 3. So it would be 2.5, negative 2.5. Okay, so a negative 1 times 2.5 would be negative 2.5. Negative 2.5 times negative 2.5 would be a positive 6 and 1/4. So the y coordinate is 6 and 1/4. Okay, so the vertex, so this point right here is 1/2, 6 and 1/4. We know the axis of symmetry, the x-intercepts we know, so the x-intercepts are negative 2, 0 and 3, 0. The y-intercept, that was the point that we used to find a, so 0, 6. The vertex is a maximum, domain, all real numbers, and the range be negative infinity. So it's going to go from negative infinity to positive 6 and 1/4. Okay, let's try that with this problem. So intercepts, we have an intercept at positive 3 and positive 6. So it would be x minus 3 and x minus 6. Okay, and the part that you have to remember is to find a, pick a point that you know the coordinates of from the graph. So I'm going to pick this point right here since I don't know the y-intercept this time. So I'm going to use the point positive 2, positive 4. Okay, and with this point, so I'm going to plug 4 in for y. I'm going to plug 2 in for the x's, and then I'm going to solve the equation for a. So when I do so, I get 4 equals a times, okay, so I plug 2 in for x, so 2 minus 3 would be negative 1. Plug 2 in for x in the second set of parentheses, 2 minus 6 would be negative 4. So I get 4 equals a, well, let me back up here. So negative 1 times negative 4 would be positive 4. So I get 4 equals 4a, divide by 4, and a equals 1. So a is a positive 1. So this is our equation. Okay, and then, so it asks for form. So we're in intercept form. I'm not sure quite why that question's there. Okay, so we're in intercept form. The vertex, okay, so to find the vertex, we need to find the axis of symmetry. So halfway between 3 and 6 would be 4 and 1/2. So the axis of symmetry is 4 and 1/2, which means that the x-coordinate of the vertex is 4 and 1/2. So we plug 4 and 1/2 into the equation to be able to find y. So we would have y equals 4 and 1/2 minus 3 times 4 and 1/2 minus 6. So 1 and 1/2 times a negative 1 and 1/2, and that would be a negative 2 and 1/4. Okay, so that's our vertex. The vertex is at 4 and 1/2, comma, negative 2 and 1/4. Okay, the x-intercepts, we know they are at 3, 0, and 6, 0. The y-intercept, okay, so looking at the graph, we can't identify the y-intercept because it doesn't go far enough to cross the y-axis. So anytime we want to find the y-intercept, we plug 0 in for x. So if I go up here to my original equation, if I plug 0 in for x, so that would be 0 minus 3. So 0 minus 3 would be negative 3. And then 0 minus 6 would be negative 6. Negative 3 times negative 6 would be a positive 18. So the y-intercept would be at 0, positive 18. Okay, and the vertex would be a minimum. Okay, in this problem right here, so it's given to us in standard form. If we want to rewrite this in intercept form, we would factor it. So if I factor this, it would then be x and x. It would be minus 6 and positive 2. Okay, so we started in standard form, we factored it. It's now in intercept form. So our intercepts would be at positive 6. So 1, 2, 3, 4, 5, 6, and negative 2. The axis of symmetry would be halfway between negative 6 and, positive 6 and negative 2. So if I add those together, so 6 plus a negative 2 divided by 2, so I get 4 divided by 2, which is 2. So the axis of symmetry, so halfway between those 2 points is right here. So x equals 2, which means that the x-coordinate of the vertex is 2. Okay, and then anytime I know x, I can plug that back in to find y. So if I plug 2 in for x, I would have y equals 2 minus 6 times 2 plus 2. So y equals a negative 4 times 4. So y equals a negative 16. So the vertex is at 2, negative 16. So it's going to be clear up here off of our graph. The x-intercepts, we know that. Again, the y-intercepts, we can either get the y-intercept from graphing it, or we can find the y-intercept by plugging 0 in for x. So just go back to our original equation, plug 0 in for x, and solve for y. Okay, to get this into intercept form, first thing I would do is factor out the greatest common factor. And since the first term is a negative, I'm going to factor out a negative 2. So I factor out -2, so that'd give me x squared minus 2x minus 8. Then factor x squared minus 2x minus 8, so I'd have -2 times, and then factors of x squared, x and x, factors of 8, 4 and 2. So it would actually be x minus 4, x plus 2. So our x-intercepts would be at +4 and -2. Okay, then from there, find the axis of symmetry. So halfway between +4 and -2 would be right here at x equals 1. So the x coordinate of the vertex is 1. The axis of symmetry is 1. Plug 1 in for x. Plug 1 in for x and solve for y to find the vertex. The x-intercepts, we know from looking at our graph. The y-intercept, we can actually cheat. You can look up here. Remember, in standard form, the value of c is going to tell us the y-intercept. So the y-intercept would be at 0, 16, and the rest is the same as what we've been doing. Last problem here, to put this into intercept form, factor out the greatest common factor. So the greatest common factor of these two would be 4x. So it'd be 4x times x minus 4. Okay, so this is intercept form, factored form. So set 4x equal to 0, solve for x, so you get x equals 0. So that's one intercept. Set x minus 4 equal to 0, x equals 4. Okay, those are my two intercepts. From there, find the axis of symmetry. So the axis of symmetry would be x equals 2, which means that our vertex has an x coordinate of 2. Plug 2 in for x, solve for y, and off we go. Okay, so that is the lesson on graphing from intercept form. Kind of a quick overview of it, but hopefully that can get you a good start. If you have questions, make sure that you come in and visit with your teacher.